Hello student, this is another third question on chemical analysis. This question is a bit unique, so however it's not that difficult, so I would like to show you how to do it. Now in this substance P is a mixture of two potassium salts. Now all potassium salts are soluble in water, and so it's a bit challenging to identify what are the potassium salts. Let's look at the question now. As usual, we look for something that are the reagent that are familiar. So can you find something familiar? We have carbon to lime water and white PPT form. That is familiar thing. What gas do you think it is? Lime water, white PPT form. Then you have it is must be carbon dioxide, yes. Another one that is familiar or that you can find from the flow chart must be this one, nitric acid followed by barium nitrate. Where can you find this? Look at the table again. Can you find barium nitrate followed by acid? No, it's here. Can you see the white PPT? Yes, this is the action. It shows that the solution must have contained certain sulfate and ions. Now, this white PPT, just like this white PPT, when you add silver nitrate as a name, and the name must be barium sulfate. It cannot be any other substance. So remember, this white PPT as a name is known as barium sulfate. So this white PPT over here must be barium sulfate. Okay, another familiar answer that you can think of is this white PPT. Do you know why the lime water turns milky? Lime water or white PPT from lime water when carbon dioxide is bubbling into it. Now this white PPT actually has a name and is known as calcium carbonate. In case you do not know calcium carbonate, what happens is this. Carbon dioxide reacting with calcium hydroxide, which is the lime water. It gives you calcium carbonate and water. Right, that one is calcium carbonate over here is the white PPT you always see, in case you do not know. So that leaves us back to the same flowchart again. Sulfate. So barium, this is a product. Barium gives us this barium component. The sulfate must come from not here but here. So in other words, this solution here must contain something sulfate. It's a bit tricky over here because this sulfate could be contributed by the sulfuric acid, because this solution was mixed with or added with sulfuric acid. Now it might look difficult to solve, but think of it carefully. This solution added with an acid give you carbon dioxide gas. So what can you tell me about this? When would acid give you carbon dioxide gas? Yes, this solution here must be a carbonate, because only carbonate react with acid to give you carbon dioxide salt solution. And this must be a carbonate. What carbonate can it be? If you think carefully, the answer is right on top. What carbonate can it be? Yes, it must be potassium carbonate. So potassium carbonate reacted with sulfuric acid to give you 2 or 3 products: salt, carbon dioxide, and water. So water, which is not shown here, but actually should be another water. You have carbon dioxide, salt, and water. What do you think is the name of the salt, if there is a salt? Yes, it has to be potassium sulfate, because it is sulfuric acid. So potassium carbonate reacting with sulfuric acid gives you carbon dioxide, salt, and water. Because the water and the potassium sulfate dissolve in water to give you this solution. And there you have it. Yes. You can see the answer. Now this part here, I'll explain why this is not necessarily prudent. Well, it's because you use sulfuric acid over here. So this sulfate, or this sulfate here could have come from the unreacted sulfate from sulfuric acid. And we need to do further tests to prove that. But what sodium must be present in the mixture? Potassium carbonate, because of carbon dioxide gas being produced. If there's no carbonate, there will not be any carbon dioxide produced. Okay, and the rest of the answers are over here. In fact, you can download the answer from the LMS. And that's it for this question.